All right, I think we're going to get started here. This is a topic that we could talk about for all day, so we're trying to squeeze this into 45 minutes, so we're going to get started right away. Thanks everybody for joining. My name is Francois Lascelles. I'm Chief Architect at Layer 7 Technologies. Today's topic is Federation Evolved, how Cloud, Mobile, and API changed the way we broker identity. And presenting with me today is Ehud Amiri, who is Director of Product Management at CA. So just a little bit of housekeeping before we get started. If you have any questions, we'd love to hear about it. Just chat questions on the WebEx chat, and we'll try to go through some of them at the end of the webinar. There's also a Twitter hashtag if you want to, if you prefer that channel, go for it. And also here's a few social media links that you can follow us on. And if you have any use cases, we'd love to hear from you. If you don't want to talk about them publicly, reach out to us, maybe on Twitter or by email. We'd love to hear from you. So I will now pass the ball to Ehud Amiri, who's going to present to you the first part of the webinar, and I will talk to you halfway through. Thanks.
Okay. First, great to be here. Kind of opportunity for me from CA side to talk to the Layer 7 customers, which is really exciting. Now let's see if I can even figure out how to change the slides. Yes. Okay. My name is Ehud. I'm a product manager in the security business unit at CA, and my focus for the last couple of years is really around federation. And as I said, with getting Layer 7 together, we are building an interesting picture for federation space as part of other activities as well. But from federation perspective, this is becoming very interesting and exciting time. We really view this session as kind of a continuation of a different thread that we had for the CA customer base, and I encourage you to follow this link and listen into the previous session in that context, talking a little bit about unifying security across web, API, and mobility. Really talking a little bit about the multi-channel of an application. This will be a common theme that I will, get back to that through this presentation. The topic for today is how federation evolved, or the concept of the new federation, which really map very well to the other session about the multi-channel of an application. So with that, let's get started. So federation is an exciting space, and for us, federation is really about standard-based identity interaction or identity collaboration, federation. So that's really about the space. And as you can see from this slide, the purpose of this slide is basically to say, federation includes multiple different standards. Some of them are a new standard or emerging standard. Some of them are a little bit older, and this picture is changing, right? So this is the picture relative to today. But if I had the same discussion like a year or 2 years ago, the players were completely different, and the size of the elements was completely different. So you can see here names like OpenID Connect taking a much broader role, and then you can see names like maybe SPML taking much smaller role here. So very dynamic environment, keep changing all the time. And so the way I like to think about federation and how this is changing and evolving and all of that is actually this slide. First, I like really much the picture of Charles Darwin, but the statement is true, right? It's a survival of the fittest. It's really about about the standards that kind of continue to evolve because they are driven by real life use cases that are driving the growth. They are driving a much better adoption of the standards. Without that, standards are just an academic exercise for us identity and access management gurus or groupies. But with the use cases, it's becoming critical to the business. It's becoming enabling to the business, and then that's where we see tremendous growth. So this is the picture there. So when I think about federation and when I think about the use cases and how things are evolving, it's really about macro general technology trends that are driving it, because again, it's all about the use cases, it's all about the usage. So over the last few years, no big surprise, we've seen tremendous growth in terms of cloud, in terms of mobility, in terms of social, organizations enabling their websites to accept social credentials. So social is definitely a critical aspect of what we are going to talk about. Topics like big data and all of that. So these macro trends are kind of driving the emerging new sets of use cases. We will spend most of the time today to talk about cloud and mobility. We will touch a little bit about social, but all of these trends are very critical to the growth of technology as a universe, but specifically for federation and the role of federation in enabling organizations to adopt and evolve and be part of these tremendous changes. So federation, a prime example of a federation standard will be SAML. It's actually a standard that is with us for a long time. Most of the development of the standard was somewhere between the year 2001 and the year 2007, so quite a long time ago. It is about two organizations or more exchanging information and collaborating. And until 2007, it was one of these standards that were, making a lot of sense, getting us identity people, excited, building products to that. But it had a limited impact on the general environment and what we will call at that time, 2007, mild success. That would be the right categorization, I think, for the adoption of the standard at that time. CA at the time it was Integrity, later on acquired by CA, was part of writing this spec and very active in the participation there. And then something happened, and that something that happened is actually called SaaS applications or cloud adoption. So when organizations started to use more and more SaaS applications, the SaaS application vendors found themselves in an effort to streamline the experience for their users, right? And it's all about the use case again. It's the use case of the SaaS application, such as Salesforce, wanting to create a seamless experience for the employees, so they can use their credentials, they can authenticate using the normal authentication methods that they use, but they will get streamlined access to the SaaS applications. And so that was the fountain of youth, or actually the accelerator or killer use case for SAML at the time, really cloud adoption. So as organizations are using and adopting to use more and more SaaS applications, they rely more and more on SAML and SAML protocol and different flavors of that and different profile of that and all of that. And it was really at the time between 2007 till the last couple of years, it was really about browser-based interfaces and getting to the single sign-on experience, the seamless single sign-on experience enabled by federation, enabled by SAML 2.0 mostly. And so that is fun. So to what extent we have this cloud adoption impact? This is one example. I like to call it based on a true story. One example of a real customer, financial organization in the U.S. That started to do their usage of federation back in 2007. So at that time, they came to us and said, we heard about SAML. We know that you are doing SAML. We want to buy 5 partnerships, 5 connections between our organizations and our partners. That will probably be enough. And that was 2007. Going fast forward, we work together with the customer, and the customer is using more and more federation. Fast forward, last year, they reached the point of using 100 partnerships. So for them, large financial organizations, they provide service to other smaller financial organizations, and they started to embrace federation. They found that this is a way for them to accelerate adoption of their services, and they started to offer their partners to federate to them mostly, and that was driving the growth from the original vision of let's do 5 partnerships with the 5 biggest customers that we have, to enabling 100 customers and really their biggest customers to use the solution. And when we had this conversation recently about where they see themselves growing, they are saying that they want to basically embrace federation as their primary way to integrate with their partners. So they are talking about hundreds and hundreds of partnerships, and the growth there is just still accelerating. And this is based on SAML. This is based on their customers' needs to integrate with and get this single sign-on experience with them. So that's kind of a data point of how much cloud is impacting federation. And just another perspective, another thing that we started early this year was to have like an official CA Federation Partner Program. And in that partner program, we accept multiple SaaS applications, and we basically test and document a runbook and a step-by-step instruction on how to set up federation between, let's say, SiteMinder or CloudMinder and multiple SaaS applications. So we are building this catalog, and that is just showing us again, these SaaS vendors are supporting SAML in a big way. And federation and their growth also, when they begin to think about mobile applications and other standards, it's all about using standard-based federation for them, and we've seen a tremendous support from that perspective as well. So when we are thinking about cloud and federation, and I'll stop with this slide and get transition back to Francois. We also shipped CloudMinder, and the next logical way is when we started with an on-prem product to enable Web SSO. We continue to enhance that with federation capabilities. Federation became a first-class citizen somewhere between 2007 and 2010. It became like a major initiative, and for us, we are seeing more of the openness, more of the collaboration between parties, and suddenly it makes sense to have CloudMinder, basically federated single sign-on as a service, as part of a broader IAM as a service solution that CA is offering, and their 7 capabilities will be added to that platform at some point. So this is kind of our snapshot of where we are today. CloudMinder 1.1 is available. It's actually a combination of 3 services: identity management, federated single sign-on, and strong authentication. And the major use case that we are seeing there is providing these capabilities of identity management, federated single sign-on, and strong authentication to SaaS applications and also to on-prem application in a hybrid scenario when the customer is deploying multiple different solutions on-prem, multiple growing number of solutions from cloud, and creating a seamless experience for both sides using CloudMinder. With that, kind of talking a little bit about the cloud and how SAML was, got to a new life, if you like, with the cloud adoption. We'll complete this picture with talking about mobility and talking about new emerging standards that are also equally important these days. And I'll transition back to you, Francois. Let's see if I can figure out how to make you a presenter again.
There you go.
Okay, you should have control.
Yeah, thank you, Hood.
Cool.
Okay, so let's talk about mobile for a bit. Mobile first. So we've talked about in a previous webinar, you're reaching out to your audience via several channels. Your audience wants to reach out to you as well through lots of channels, including mobile. And for a lot of people I meet, mobile is really at the top of priorities for these channels, right? So a lot of people talk about mobile first. In the end, it doesn't matter, right? Mobile first, mobile second, whatever. Mobile is important. Raise your hand if you don't care about mobile right now. See what I mean? So mobile, what is it that you want to secure? When you're talking about access control for mobile, so first of all, you have a mobile browser. Maybe you have two mobile browsers on your mobile devices. That happens. And so for those browsers, those mobile browsers, you're accessing web applications. So a lot of the same patterns apply for web applications, whether they're coming from mobile or not. But all the other apps on your mobile device get their data from APIs, not from web. So really, what we're talking about when we're talking about mobile access control is really about API access control. Sorry for this, these little arrows not rendering properly here. So what you need to do is reconcile user experience and security. UX here is user experience. Reconciling, user experience and security is very tricky. It's a very tricky balance. On one hand, exposing data to mobile devices is considered risky. It increases your attack surface. IT organizations struggle with supporting BYOD in a secure way. But on the other hand, mobile user experience is also very important. And the reason is this. UX is a very reliable predictor of adoption, right? What if you implement this massive mobile initiative and nobody uses it? That's a disaster. So user experience drives adoption. Adoption drives success. You just can't ignore UX. And user experience is particularly challenging on a mobile device. So you do need to authenticate users, but you don't authenticate them all the time, or at least you're not prompting them all the time with different passwords. Give them single sign-on. Single sign-on is a prime mitigation for those evil UX disruptors, and it helps reconcile user experience and security. So we've established that you need to provide single sign-on for your mobile apps. So what? Well, the thing is that mobile apps and web applications don't work the same way. Mobile applications tend to be isolated one from another on a mobile device. So if you look at web applications, if you're consuming multiple applications from your browser, you have the ability to get cookies that are reused across different applications within a domain, right? If you go on your iPad and you log on to, let's say, gmail@google.com, and then in another tab you log in to, let's say, docs.google.com, you don't have to log in again, right? These different web applications share an authentication context. On the client side and the user agent, you can rely on that domain cookie to be reused. But in mobile applications, each application works in isolation. They each have their own space. Mobile applications each consume their APIs, and multiple applications can call the same API, but they still each to have their own access token in order to consume these APIs. And so that makes it harder to provide single sign-on on mobile device. And on top of it, you have very often situations where the mobile application is from a different party as the API provider, right? Very often API providers will expose a public API that third-party developers can code against. So that makes it even harder to provide single sign-on across mobile applications. I see a comment from Richard Sen there. You like the Charlie Manuel picture. Thank you very much. So client-side sharing of authentication context. So that thing I just said about mobile applications working in isolation, well, I was actually lying about that. It turns out that a group of applications can share a keychain. A keychain, maybe this is a iOS-specific terminology, but the same thing applies to other platforms as well. And by group of applications, what I mean here is really a set of mobile applications that are signed by the same developer key. So if you develop mobile applications and they're all signed by the same developer key, you can set up your application to share a keychain, and therefore you can share something like an authentication context. So this is critical for mobile SSO. By sharing this keychain, the group of applications can share an authentication context in such a way that avoids having to prompt the user for authentication when switching between these applications. So the first application in the group would, the first time get credential, the authentication is performed, a token is issued from that, and then other applications can piggyback on that existing context to get their own access token. So we'll talk a little bit later about which standards, which patterns are applicable in this case. So that's great for applications that all belong to a common domain, right? But obviously other applications each work in isolation still. So that still applies. Otherwise, that'd be a security issue. So sharing an auth context across a set of applications using a shared keychain is great, but it doesn't cover the third-party app or apps that cross domains, if you like. So for third-party apps to share something like an authentication context directly, it needs to be communicated somehow. And a well-known method for achieving this is through app-to-app redirection. So you have an application on mobile device, mobile applications can register a URL scheme so that when an application redirects to a specific URL, if it belongs to another application, you're effectively switching to the other application. And as part of that URL, an application can include a callback address so that scope can be redirected back to that initial application. And you might have seen this already. This is an existing pattern that some applications use to exchange information, such as an authentication context. For example, on iOS, before the Facebook login was built into the platform, some applications were using that where you would say log in with Facebook, the application would redirect to Facebook, you would express consent, be redirected back to the application. So through this pattern, you can pass an authentication context across third-party applications. This pattern it sounds very promising, but it does have limitations. It does have a risk around unverified URL schemes. So this is a quote from Apple here that says that if more than one third-party app registers to handle the same URL scheme, there's currently no process for determining which app will be given that scheme. So effectively what that means is that imagine a malicious developer developing an application and registering a well-known URL scheme in order to attempt to introduce itself into that handshake, if you want, and retrieve an authentication context that it really is meant for another application. So when you so using that type of redirection leaves you open to that risk. And you know, in the context of a social login, the risk is limited to you know, maybe that malicious application impersonating you on that social platform or something like that. But when you're looking at this from the perspective of, for example, an enterprise use case, you may end up in a situation where that malicious application could end up with that authentication context that really was meant for that enterprise application that allows it to maybe retrieve data that it shouldn't be able to retrieve. So there's definitely a security risk involved with that pattern. So the client-side mechanism we described so far assumes that the mobile application involved are actively participating in federation, right? So if they're within a domain, they participate by you know, accessing the same auth context and sharing that information. When you're talking about app-to-app redirection, there is still an active participation because you need to pass the ball to the other application through these redirection URIs and things like that. So what happens when you want to involve a pre-existing application into a single sign-on system, right? This is a very big challenge at best. And one of the approaches that seem promising is app wrapping. So app wrapping is usually used to add a security layer on top of an existing application, but application wrapping effectively recompiles the app with the new developer key. So it is, in fact, possible to use app wrapping to extend a shared keychain to a third-party app by recompiling that app. Of course, a third-party app most often interacts with a third-party API on the server side, so the ability to access the shared auth context is obviously only part of the story, right? And you need to know what to do with it, and that might not make sense on the server side on that third-party API. So in some cases, what needs to be federated is not only the user identity, but the API itself. So let me illustrate this with a concrete use case. So imagine that you have a team of social media gurus working for an organization. Let's call them Kevin, James, and Brent. And they are posting on a social media platform on behalf of an organization that they work for. And they do that from their mobile device. So the mobile app that they use from the social media provider, it uses its own API, of course. And each user is logged in using the organization's account. That's what enables them to post on behalf of their organization. So there's a couple problems with that. So first of all, the organization has absolutely zero control on this at runtime. Traffic bypasses the organization completely, right? It's a classic cloud case. And the second problem, perhaps the bigger problem, is that the social media account associated with to the organization is shared across a number of users, and this is a very big security risk. We've seen countless organizations being, you know, Twitter hacked in the last few years, and this is very embarrassing at best, but it can have some very disaster consequences as well. So wouldn't it be much better if Kevin, James, and Brent were actually logged in using their enterprise credentials instead? So right there, the organization gets back a lot of control, right from the start, right? So instead of the organization's social media identity being shared across the social media team, team members are authorized to act on its behalf, and these permissions are managed by the organization itself. The API calls from the mobile application are directed to the organization's API broker. So I'm introducing the concept of an API broker here. And this API broker can look up those authorization rules and decide whether or not a specific user is allowed to post something on behalf of the organization. The API broker can also filter those posts in real time. You know, maybe Bren did not, you know, intentionally do something bad, but maybe that person he was trying to retweet is actually on some sort of blacklist, let's say. You know, just as an example of something that could be filtered in real time there. So the point here is that the organization gets back control over what gets pushed on its behalf on a social media platform. And this applies outside of just the social media use case, just for any API integration between the corporation and, for example, a partner. So what is needed to broker this? So on the server side, it's clear what you need. You need an API broker, something that receives API calls, authenticate users against an enterprise identity store, apply rules regarding authorization, etc. That API broker also needs to be able to act on behalf of the organization's social media account. So the secret associated with this account remains a secret. And it really only needs to be known by an administrator responsible for managing that session on the API broker itself. So now what do you need on the client side, though? Well, one option is just to have a different mobile application, right? And that's what we see very often. So why a new mobile application? Well, you need to redirect the API calls to the broker, right, in order to have this taken into action by the organization. So you need to know to also authenticate the user with the enterprise identity. So it's a lot easier to achieve that with a new application, but there are some other approaches being considered. So, for example, you can think of a local proxy. That's one option that is being considered, but that doesn't seem very practical because you need to set up the enterprise ID, and I don't know how a proxy will help with that. But another interesting approach is to use a wrapper on top of the existing app. So remember that using the wrapper, you could access an enterprise ID authentication context. Well, that could come in really handy in this case. Well, now, if you trap the API calls in the wrapper as well, you can redirect them to the organization's API broker, and you actually have something useful to do with it. This could be a very promising approach in order to support this case. Okay, so there's a few standards that we need to talk about as part of this presentation. Standards are very relevant for federation in the case of mobile and APIs in general. And the first one is OAuth. So OAuth really is a standard that defines how an application is issued an access token, and that access token is used to consume an API. That's what OAuth is about. So OAuth 2 is the latest OAuth standard right now. OAuth 2 defines many different grant types. Some of them will involve a redirection to an authorization endpoint. Not all of them. A lot of people, when they think of OAuth, they assume that it involves some sort of redirection. It doesn't need to be. That's how OAuth started back in 2006, but now OAuth supports a lot of different grant types. And so an application will get a token that allows it to consume an API, sometimes on behalf of an end user, and then inject that token in a REST API call to the OAuth resource server. It's not illustrated here. So on the organization side, if you are an API provider, that's a very important thing that you need to implement. You need an OAuth authorization server, the token endpoint, authorization point. You also need an OAuth resource server that will allow you to let the application consume the API using an access token. So OAuth, I would say, is very often misunderstood. OAuth by itself does not provide any federation, right? OAuth is not about federation. It's really about describing how an app gets that token. The other thing is around security. So some famous OAuth implementations have given OAuth a bad name. But that really is because they implemented OAuth in an insecure way. So I think it's important to realize that OAuth by itself is neither secure nor is it insecure, right? You need to implement it in something that, in a way that is going to be secure, that's going to prevent phishing attacks and things like that. So social login. Social login is a very popular pattern these days. And a service provider, right, an API provider or just a service provider in general has obvious reasons for subjecting a user to a social handshake. The primary use case for that originally was really for a provider to be able to post something on behalf of the user on a social platform, right? But as part of that handshake, the user identity actually needs to be verified by the social platform. So somebody had the brilliant idea at some point to leverage that to delegate the authentication of the user. So you might be used to seeing that today as an end user when you go to a website. This is not only for mobile. I think it applies in lots of different cases. But you might have seen this where you go to a website or an app and it allows you to log in with Facebook. So what actually happens there? When you click that little button, log in with Facebook or Twitter or Google or whatever the social provider being used, what happens is that the service provider redirects you to that social provider, and the social provider will seek for you to get consent for this flow. So very often it looks like this: do you authorize whatever service to access basic information, yes or no? And if you say yes, you're redirected back to the service, and now the service has an access token, an OAuth access token. And although OAuth typically is used to consume an API on behalf of the user, in this case, the access token is used by the service provider just to call like a user info API on the social provider that allows it to determine that, in fact, this is user Joe, this is his email address. I didn't need, as a service provider, to authenticate that user directly, which is great for the user experience of the user. But it's also great for me as a service provider because that avoids me having to maintain a shared secret with that user to establish its identity. And this is often misunderstood. People think, wow, if I no longer authenticate my users directly, I'm going to somehow lose control of my users. That's not the case. You can still maintain a lot of rich information about your user base without having to maintain a shared secret with them. You're just leveraging the social login pattern to confirm the identity of the user. Once you have that, you can maintain a lot of information about your user base. You could even set it up so that each user can log in on whichever social platform they prefer and correlate them on the server side. So this is what the social login pattern is about. It's a very important, very popular pattern used these days and very relevant to what we're talking about today. OpenID Connect is also a standard that's very relevant here, and effectively OpenID Connect is just a formal standard of that social login pattern that I've just described to you. So OpenID Connect builds on top of OAuth 2, and note that OpenID Connect has nothing to do with OpenID, which is a previous standard that hasn't had a lot of adoption. OpenID Connect is different. It's just something on top of OAuth, and it defines that handshake. It defines that user info endpoint. It also defines the use of JWT, JSON Web Token, which by the way is pronounced JOT, to format claims about a user. So it's very analogous to SAML, and a lot of people think of OpenID Connect as potentially maybe replacing SAML in the long run. So there's a lot of excitement about OpenID Connect. It remains to be seen if it's going to have a lot of adoption. But one of the advantages of using OpenID Connect is that there's no, you're lowering the bar for a relying party to participate in that type of federation handshake. So there's no SAML, there's no XML, there's no digital signature, and even though there's a JSON-based identity claim in the form of that ID token that's created by the OpenID Connect IDP, it doesn't need to be used, right? The relying party can just get the access token and call that user info endpoint and say, here's a token, give me information about that user, get back the information in the API response. It's very lightweight for the relying party. And because it's lightweight, things like JOT and JWS and those types of standards tend to be very mobile friendly, if you want. So another set of standards that are very relevant here, I've talked about OAuth as a way to get an access token. You know, an application gets an access token from an API provider in order to consume that API. And OAuth 2 defines 4 core grant types. Most of them involve a user authentication. But the idea is, how would you use a pre-existing authentication context in order to get an access token? And there are some OAuth extension grant types that are defined which enables that. So OAuth is meant to be extended as a standard. And here's a couple of examples. There's the SAML bearer grant type, where an application would take an existing SAML assertion, go to an OAuth token endpoint, say, here's a SAML assertion, can I please get an access token for that, and get back an access token. The same thing, very analogous to that one, is the JOT bearer grant type, where you're doing the same thing. Instead of presenting a SAML assertion, you present a JOT, and that could be itself the result of an OpenID Connect handshake, right? So imagine an OpenID Connect handshake done once in order to get the authentication context, and have multiple applications like we were describing earlier that have access to that authentication context, now can take that and exchange them for their own access token. So in both cases, that type of OAuth handshake does not disturb the user experience. The end user is not subjected to a challenge in order to complete that handshake. So the mobile access gateway. So I've talked about different standards, different patterns, and before I wrap up my part of the presentation, I just want to introduce one piece of Layer 7 product that is relevant to today's topic, the mobile access gateway. The mobile access gateway is a flavor of the Layer 7 gateway, which caters specifically to mobile device. So it's part of our API management solution. It provides secure mobile endpoints. It lets you manage permissions, excuse me, across not only users but devices and applications. So when an API is being called and an access token is presented at runtime, the mobile access gateway, depending on how the handshake was established, has the ability to correlate a token with a user identity, a specific device, and a specific application. So that trio of identity, if you want, is very powerful. And from a mobile API delivery, the mobile access gateway inherits all of the enterprise class functionality that you get from the Layer 7 gateway. It allows you to integrate your APIs into your existing identity stores, into your existing data sources. It allows you to scale to whatever volume is required. The mobile access gateway is also there to increase developer velocity. So we're actually providing an SDK, a set of libraries for both iOS and Android developers. And those libraries are used to abstract all of those handshakes that I've described so far. It's all based on standards, so it is optional. But if you're in a situation where you're developing mobile applications to consume these APIs, these libraries are there to help you. And on the server side, configure, not code, right? So because of our gateway technology, you don't have to code all these APIs. You don't have to code all of the integration bits. It's a configuration approach. Form factors, this is available as a gateway, as a virtual appliance. You can deploy that on the cloud, on premise. You're getting all of that with the mobile access gateway. And from an access control and user experience perspective, we, through this provision a PKI onto the mobile device, we enable that mobile app-to-app single sign-on experience that I was describing earlier specifically for a domain of applications, and it does implement all the latest standards around OAuth, OpenID Connect, JOT, JSON Web Signature, encryption, and things like that. So I'm going to pass it back to Ehud.
Okay, great. So I'll try to be quick, kind of closing the discussion and leave some room for questions and answers. So today we talked about a little bit the cloud, the mobility, the social. We touched, at least we touched on some level on that, and how the enterprise need to become more and more open, and that a modern application is really an application that has multi-channel. So let's just look at that just a little bit closer, right? With all of these changes, identity stays in the middle. It stays as a point of control, and in cases where it is not a point of control, we have ways to make it back into the enterprise control, so we have control around the identity. And we continue as the CA Security Business Unit, we continue to focus on identity as that point of enforcement, as what we like to call identity is the new perimeter, as that place where organizations can implement multiple security controls. So specifically what we try to emphasize today is that if you look at modern applications and modern services, you will see something like that. You will see that we have two major interfaces for the application. One is a website, the second one is an API. And these two interfaces are serving multiple tools, multiple clients, multiple different types of users. It may be internal users, external users. It may be from mobile devices or from a browser. It can be, as in the case of using a mobile device, that you have mobile apps and you have a mobile browser, and in some cases you move between them, right? You read an email, you see a link there, you click on the link, you actually go to a website, you open the website, it can, in theory, start another conversation with a mobile app, which in turn can be a hybrid application as well. So it's a very kind of environment that has multiple pieces, but from an end user perspective, we want to ensure that we have the same kind of controls, the same kind of experience, the same kind of authentication. And that's really why CA doing the acquisition of Layer 7 is so exciting, so interesting for us, because it is allowing us to talk about this picture, about the picture of these two interfaces, about SiteMinder, about Layer 7, about protecting these two interfaces, about enabling these two interfaces, and about providing similar kind of quality of service, if you like, in terms of the identity dial tone for the complete application. And as we also kind of try to stress through the conversation today, it's also a lot about multiple different standards. The standards continue to evolve. New standards are appearing. They are implementing some integrations with older standards, but they are all there, right? So a modern application, a modern service will need to support multiple federation standards, and will need to provide, again, a seamless experience. And that's really the key point here, is that we have multiple different use cases, but they all need to provide a very fine user experience to the end users, and they all need to provide similar user experience, right? And that's kind of the focus that we have, and that's the thinking that we have, and that's really the concept of the new federation, implemented by CA with Layer 7 is a major part of that vision, supporting multiple channels, multiple standards, protecting the web interface and the API. So that's kind of the thought of today, and I'll stop here and just open it for more questions from you guys.
I see a question from Richard Sands asking whether the mobile access gateway, the MAG, excuse me, can be thought of as at the very high level as SiteMinder for mobile devices. So I think sure that's one way to look at it. The mobile access gateway definitely integrate with SiteMinder. So if you have some SiteMinder access control rules and user authentication implemented through SiteMinder, that will hook up to the mobile access gateway, so that when you do these handshakes from a mobile application to get those OAuth access token, you will indeed be able to do that from the MAG, integrating with SiteMinder. That's a good question. Alex, I'm assuming these are questions coming from other channels. Is API brokering supported by common MDM software like AirWatch? How does Layer 7's product differ from MDM provider like AirWatch? Right. So we're really coming at this from an API management perspective, if you want. We're not an MDM player, nor I would expect an MDM player to focus on API management. Like I explained in one of my earlier slides, what it comes down to is that those mobile applications consume APIs, and what needs to be secured and control access for are these APIs, and that really is the touch point, right? People manage their APIs through our infrastructure, and because those APIs are consumed by mobile applications, they're asking us to do all of these things. We're not trying to be an MDM here, but it really extends the whole solution when you're exposing APIs to mobile devices. Somebody's also asking, what's the Android equivalent of a shared keychain? And is Android equally vulnerable as Apple? Yes, I believe so. For the vulnerability part, I'm not an Android developer myself, so I don't know what the terminology is for the equivalent concept on Android. I'm afraid I don't have the answer to that question. Are we getting anything else, Alex? Ehud, anything else you want to add to these questions? Or oh, here's another one. Is it possible to set up an SSI infrastructure in a mobile device to facilitate a secure handshake with an enterprise application? I'm not sure what SSI means here. And we're also getting questions to share the slides. Does OAuth require a prior handshake between OAuth Enterprise Server and the client application? Yeah, so obviously at some point you need to authenticate a user. So it could be, for example, an OpenID Connect type handshake, which is really an OAuth handshake, in order to first establish the identity of a user. And through that, you creating that authentication context that we were talking about. So yeah, obviously at some point you do need to authenticate the user initially. That's important. And just so for those people asking for the slides, I'm hearing here that we'll be sending out an email tomorrow morning with the slides and the webinar recording, so you'll be able to get all of that material there.
Yeah, I do see another question asking for more clarification on the mobile SDK. If you can explain it again, how it works. Okay.
So the SDK that I was talking about as part of MAG, so that comes with the Mobile Access Gateway version 2.0. And the way that works, as an application developer, whenever your application makes an API call back to your API, it will do that through our library. So you will interface with that library whenever you need to make those API calls. And the library layer, the SDK that we provide, when it receives an instruction to make an API call, will determine whether or not a handshake needs to be made. Do we need to get an access token? In which case, it will be able to retrieve the authentication context, do the handshake, get an access token, inject it in the right place in the API call, etc. If a user needs to be prompted for authentication, the library will also do that. So it really abstracts out all of the API calls and all of the identity requirements around them. That's how this SDK works. So we seem to be running out of questions. I'll just wrap it up. Thank you so much, everybody, for joining this webinar. I had great attendance, and hope you got something out of it. And stay tuned for the next webinar.